So this video is going to explore more, is it always true that we should always have a centralized system? And one of my favorite lines from my mentor always said, the answer to every question that an industrial and systems engineer should answer is it depends. So no, centralized system is not always the correct answer. For this example that we just did, yes, centralized system is better because the decrease in inventory cost and the decrease in facility costs make up for the fact that transportation costs go up. But that does not always happen. And so like, what is at the heart of that trade-off? Well, let's think about the product characteristics and what influences this total expected logistics cost. And so if we think about the total expected logistics cost, if we have higher variability of an item, then we get more safety inventory benefits from centralizing. And so the idea is if you have lots of variability, then we want to centralize that so that we can have less safety stock. So that's a positive for centralization. However, transportation costs are a function of demand. And so if you think about demand and order quantity sent, if demand is really high, then you usually have higher transportation costs in a centralized system. And so what this means in kind of just like a generic takeaway is that it's common for slow moving products to be centralized, but fast moving products to be decentralized. And so this is something that actually companies like Amazon, for example, do, is things that are really highly demanded. Usually those have lower variability and they are sent a lot to the customers. And so those are things that they push to regional distribution centers, getting them close to the customer. And then slow moving items are things that they centralize. And so those are things that are slower moving, which oftentimes means there's higher variability in what is going to be requested. And so yes, we don't know what is going to, we're gonna have to pay more for transportation, but because they're slower moving, you don't have to pay as much transportation. And so this is definitely a rule of thumb, but typically fast moving products have the characteristics that are good for decentralization, and slow moving products have the characteristics that are good for centralization. You will explore this a little bit more detail in the homework problem where you have popular and unpopular variants of cars and see the trade-offs there. And so in terms of just kind of testing your knowledge, what is your intuition? So inventory aggregation will blank total expected logistics cost for a product with high demand uncertainty, low transportation costs, and large customer order quantities. Do you think it will increase, decrease, or unsure? And just as a reminder, what makes up the expected total logistics costs are inventory holding costs, transportation costs, and facility costs. Please pause if you need some more time to think about this problem. So let's walk through this problem. So if you have high demand uncertainty, that means if I aggregate, I should win quite a bit on inventory holding costs. If you have low transportation costs, this cost to transport one order, yes, your transportation costs will be higher in a centralized system, but probably at a not impacted as much. And then large customer order quantity, that means we're not sending as many orders per year. And therefore, we would say that inventory aggregation for these products will likely decrease total expected logistics costs. It would be a good idea to aggregate something that had high demand uncertainty, low transportation costs, and large customer order quantities. Of course, if you had actual numbers, you could calculate this and quantitatively make this decision. But as kind of a rule of thumb, this would be a good opportunity to aggregate, to have centralized inventory for this type of product. And so you can think about what is the impact. So when do you gain the most from aggregation? This is when you centralize. And so when you get the most benefit is when you have a high desired cycle service level. Why is that? Because first of all, you have a lot of inventory. Safety stock. And so if you just think about the square root rule, you're starting with a bigger number if your cycle service level is high. You also get more benefits when you have a higher replenishment lead time. Again, as the L gets bigger, your safety stock gets bigger, so there's more things to reduce. You can think about it that way. If you have higher holding costs, then it's beneficial because holding cost is directly proportional to how much safety stock you have. And so if your holding cost is small, even if you reduce your safety stock a lot, you're not going to make a lot of impact. But if H is big, any reduction in safety stock has a huge impact. And then, of course, the more variable the situation is, so when demand is extremely variable, that means the coefficient of variability of demand goes up. That's really a good idea of having centralization. One reason why we're talking about coefficient of variation, which is the standard deviation divided by the mean, matters is because remember, we need to also trade off our decrease in safety stock with our increase in transportation. And so transportation is directly related to this D. And so as a relative view, coefficient of variation is a good way to think about it. If that is really high, safety stock makes the inventory reduction in safety stock overshadows the increase in transportation costs. When does it not do as well? So if you have a lot of correlation between regions, if the correlation is really high, you're not going to get these savings. And so an example of when regions would be correlated is in our wonderful epidemic we're going through right now, all regions had an increase on hand sanitizer, toilet paper, etc. That means all of the demands increased. And so there would be no real benefit to centralizing that because you never get one region goes up and one goes down. And so if you have high correlation among your regions, you do not see this benefit. And so if you think about what we're talking about in terms of inventory, we're also talking about transportation. And that's something kind of we've subtly talked about throughout this lecture. And so if you think about what different types, you have high demand and low demand, but you also have high value and low value. And so if you think about the low demand row, is that typically we would want to aggregate those and use, if it's high value, you'd use fast modes of transportation. For example, air. If someone's willing to pay for that, we would do that. If it's low demand and also low value, you would probably use more cheaper modes of transportation. If you think on the high demand side, usually depending, especially high value, you may want to aggregate it because the holding cost is really high. But if it's high demanded and low, you typically disaggregate it because your holding costs are less. And so these are just rule of thumb. And obviously, if you had the actual data for this, you could do the quantitative comparison. But I point this out as there are some things you can think about. If you look at, you have a portfolio of items, oftentimes what happens is some of them get centralized and some of them are decentralized. And so one of the big takeaways is in a decentralized system, having multiple locations have their own inventory, holding costs will go up, but transportation costs will go down. And so you always need to keep that balance going. And also when you select a mode of transportation, so mode of transportation would be, would you use air shipment? Would you use UPS, FedEx, so carrier service? Would you use less than truckload? Would you use railroad? Those are modes of transportation. And so you can't select your mode of transportation and just say, I want the cheapest transportation option, because that's myopically making decisions, and then you're not considering the whole expected logistics cost, which again has inventory, transportation, and facility costs. And so you can actually find that you may pay and justify high expensive transportation modes because they will have lower inventory costs. And so one of the things we've talked about in this lecture is about aggregation. And we've basically talked about physical aggregation. But one thing you can think about in today's age is if we can information centralize, we can get a lot of the benefits of aggregation without physically being aggregated. What do I mean by that is if you go to a store and something is not there, but they can see the inventory at the rest of the network, and that customer is willing to wait to get that shipped, you don't lose the sale. That sale may be more expensive because you have to now pay shipping, but it reduces the amount of safety inventory. And here's a good example. Nordstrom's did this. And so there's a couple of links if you're interested, but they were able to actually reduce their inventory levels because they were able to virtually pool their online and in-store inventories. And so you can think creatively about what does it mean to aggregate inventory. And so just as a kind of wrap up, you should now be able to do the homework problems that deal with multiple locations. That's the book problem. And you should also understand these things for the exam.